Okay, guys, let's take a look at one more example of graphing a quadratic function. Again, we need to make sure it's written in standard form, and then I like to identify our A value, our B value, and our C value. So this time our A value is negative, so we know the direction of our parabola is turning down. Therefore, the vertex is going to be the highest point on our parabola. It's a maximum point. To get our vertical line that divides our parabola into two symmetrical parts and the AOS goes straight through the vertex, we're going to use the formula x equals, again, an AOS is a line, so we write it as an equation, x equals, and the formula is negative times the b value divided by 2 times the a value. So we have negative from the formula. Our b value is 2 over 2 times the a value of negative 1. So we have negative 2 over negative 2, which is a positive 1. So x equals, again, I encourage you to always write it as an equation. This x value is the x coordinate of our vertex, so we can go ahead and put the 1 in the x position of our ordered pair. A vertex is a point on the graph. To find the y value of the vertex, we simply insert this x value of 1 into the function. So y equals negative from the function. Again, as you can see how I model these, I always use parentheses when I'm inserting a value. The value of x is 1, and then it's squared, plus 2 times 1, and then plus 8. Order of operations, we square 1, so 1 squared is 1, and then 1 times this negative is negative 1. This is a very common mistake, is folks want to square negative 1, but you square exponents first, then you multiply. And then we have 2 times 1, and then plus 8. So we have y equals negative 1 plus 10, and our y coordinate is going to be 9. So we can go ahead and get a little sketch to see if we're going to have some x-intercepts. X equals 1, and our vertex is 1, 9. So 1, 9, we'll say that's 9 here. It turns down, so we are going to have 2 x-intercepts. If our function had turned up and was positive, we would have no real roots and we wouldn't need to take the time to try to find them because there are not any. But our graph does turn down. It does pass somewhere along the x-axis at 2 points. Okay, the y-intercept is when x equals 0. So to find the y value, we're going to insert 0 everywhere we see an x. So our y-intercept is 0, 8. It's the c value when it's written in standard form. So now let's try factoring first. So we are going to factor out a GCF of negative 1. Anytime our leading coefficient is negative, we want to go ahead and factor that out. So we have y equals negative 1, and then we're left with positive x squared minus 2x minus 8. So I just divided each of these terms by negative 1. And now we are going to remember we still have this negative. Okay, our a is negative 1. But we are going to find the x-intercept. So instead of writing y, let's erase that and put in 0, because when we're finding the x-intercepts, that is when our y coordinate is 0. So we have our negative, and we are going to factor x squared into x, and now we're going to factor -8. So I'm going to use my little graphic organizer. So we're just looking at this new part here. So here, this is a +1 times -8, and then we have -2. So what times what is -8? That gives us a sum of -2. So 4 and 2, and the 4 needs to be the negative because when I add these, that gives me the -2, and if I multiply, I do get -8. So x minus 4 and x plus 2, and we can set each of these factors equal to 0, so -1 equals 0. Don't really need that. And x minus 4 equals 0, and x plus 2 equals 0. When we solve for these, we're going to add 4. And when we solve for this, we're going to subtract 2. And gives us a -2. Put that negative out here. Okay, let's do our sketch. And we have our AOS, x equals 1. So x equals 1 is our AOS, which we will need for intervals of increase and decrease. So our domain is all real numbers. We are not restricted. X can be anything. What about our y values? We are restricted because the graph does have a stopping point. Our vertex was a maximum, but we always indicate the least value first. So it goes from -infinity up until +9. Always write least to greatest. The interval of increase, this time our increase is on the left side. As we read the graph and trace it left to right, you can see our pencil is going up, it's increasing. So from -infinity up until that x value of 1, the graph increases, so in that region. And then at 1, it turns. So when x is 1, our vertex is a turning point, and our y values start to decrease. So from 1 to +infinity, our graph is decreasing. So the interval of positive, so our graph has positive y values in this part right here. All of these, if we were to write out all these ordered pairs, all the y's would have a positive value. So when x is 2, so 2 comma, -2, -2 comma 0. So I'm just going to write that point, -2 comma 0. We are trying to list what x values cause us to have positive y values. Well, starting at -2, but we're not going to include -2 because at -2, the y is 0, which is neutral. And then all the way up until we have this point, 4 comma 0, up until x is 4. So from -2 to 4 and all these values in between, all these x values, we have positive y values. Then our interval of negative, so what's below the x-axis, giving us negative y values. We can see all the values below the x-axis are negative. So from -infinity up until -2, in this area, the y's are negative. Again, not -2 though. Then we're going to unite that with 4 to +infinity. From here to here, the y values are negative. In behavior, you can see the ends are both going down to -infinity. So we have a left end. So let's go ahead and do that first. As x approaches -infinity, as we go left, the graph is going down. And then let's take a look at the right end. So to say the right side, x is increasing to positive. So as the x values increase, the y values, f of x, they decrease.